This is the first example from the next set of notes, 9-2 2D. It's conservation of momentum still, just like before, but now we were moving in two dimensions instead of one like we were before. The first example problem reads, a 1325 kilogram car moving north at 27 meters per second collides with a 2165 kilogram car moving east at 11 meters per second. The two cars are stuck together. In what direction and with what speed do they move after the collision? Drawing right here indicates what we know about both vehicles. We have one car moving east. That's what I've identified as car A, which has a mass of 2165 kilograms moving at a speed of 11 meters per second. We have a second car identified as car B, which has a mass of 1325 kilograms moving at 27 meters per second north. Given that one's moving north and one is moving east, I know that in general they will move off in a northeast direction. The problem stated that they collided and stuck together, so there are not two objects after the collision, just one. Their combined mass after the collision is 2165 plus 1325, 3490 kilograms. This information will be helpful later in the problem. Now, to solve these problems, and as you see in your notes if you looked at them on It's Learning, we have a table to fill out. Our first line of the table is momentum of car A in both the X and the Y direction. In the X direction, car A has a mass of 2165 kilograms and is moving left to right, east, at 11 meters per second. 2165 times 11 is 23,815. In the Y direction, it has no velocity. That is because it is only moving due east and is not moving north or south at all. Therefore, 2165 times 0 is still 0. For car B, we have an initial velocity in the X direction of 0. It is moving due north and not moving left or right or east-west at all. Therefore, PB in the X direction is 0. In the Y direction, car B is moving at a speed of 27 meters per second. Therefore, its momentum is 1325 times 27, which is 35,775 kilograms times meters per second. Now, conservation of momentum occurs in both directions. Therefore, conservation of momentum in the X direction, PAX plus PBX before the collision, is equal to PABX after the collision. Therefore, 23,815 plus 0 is 23,815. Same thing for the Y direction. PAY plus PBY is equal to PABY. In this case, that is 0 plus 35,775 to once again give us 35,775 kilograms times meters per second. This gives us the momentum of AB in the X and momentum of AB in the Y. To solve for the velocity in both directions, we look at the momentum of each in both directions. Momentum of ABX is equal to the mass of AB times the velocity of AB in the X direction. Rearranging that, solving for velocity, gives us PABX divided by the mass of AB. I simply take the momentum of X, 23,815, divide by the combined mass, 3490, which we saw at the top of the page, to give me a velocity of 6.823 meters per second. The same thing occurs in the Y direction, except we use PABY, which is 35,775, divided by the combined mass of 3490, to give us 10.25 meters per second. This gives us the velocity of the car in both the X and the Y direction, and if that was all we wanted, we could stop. However, it is not. First thing we're going to do, to solve for the actual velocity, we are only simply going to Pythagorize the X and the Y directions of velocity to get the combined velocity. VAB squared is equal to VABX squared plus VABY squared. So VAB squared is equal to 6.823, etc. squared, plus 10.25, etc. squared, giving us that VAB is equal to 12.314 and a whole bunch of other decimal points. Rounding to two significant figures gives us 12 meters per second. Since we are looking for the velocity, having the 12 meters per second is correct, but we also need the direction. To solve for the angle, we go back to an equation that we used a long time ago, which is theta equal to tan inverse of VABY over VABX. Inserting our values from before and then plugging it into our calculator gives us a theta of 56.34875,66743. Rounding to two significant figures gives us 56 degrees. And since we know it is 56 degrees up from the east, that makes it 56 degrees north of east. The second example problem will be coming up shortly.